Okay, let's start.
Nice.
We're going to finish this lesson that we started the other day. I don't remember where we ended up. So, I know that we talked about strength of acids. This is really important. Okay, and we also then talked about the difference between strength of an acid and concentration of an acid or base. Okay, what makes something strong from an acid standpoint?
It's like
Okay,
giving out
a little bit more specific than that. Yes, it has to do with hydrogen.
Ability to give off a proton.
Okay, so the only way I can define an acid as strong is if it what?
it's on proton.
No.
Has the ability to
It's
come.
all
No.
easily.
Gives it all off.
It lifts weight.
Easily and
Okay?
Incredibly.
It gives off a hydrogen completely, which means it gives all of its hydrogen.
Wow.
Can I go get my
Okay? So anything that gives less than all of its hydrogens, can we call it a strong acid?
No.
No. Okay? Has to give it all off. And I showed you the other day how if I have HCl, I could break it up into hydrogen and chlorine. And if I have a mole of HCl, I would have a mole of hydrogen. This is not the case if it's a weak acid, because weak acids don't what?
Give all of it.
All of it. They don't give off all of it. They give off some of it. Now that can become a little bit trickier because how much is some?
Who knows?
Does that make
Could be
sense?
anything.
Some could be a little bit of some, or a little bit more, or you know, you see what I'm
Wait,
saying?
what if it doesn't give off any? Then it's not.
Then it's probably not an acid.
Oh.
Okay? So same thing for bases. Bases are going to completely, strong bases are going to completely give off OH minus. Can anybody tell me a few of the 6 strong acids by chance?
H2SO4.
H2SO4, HCl,
HBr,
HNO3, HBr, HI, HClO4.
H2SO4.
The strong bases are these guys with OH. Another way to know if it's a strong acid is if they cannot compute the K value. You remember talking about that?
Oh, yeah.
Because it completely dissociates, so when you write the equilibrium expression, you are dividing by 0, which is considered what? Undefined. Okay? Another way of saying that is infinite. Okay?
infinitely strong.
Then we said weak are ones that do not completely dissociate, and we will talk about there are various levels of weak acids and weak bases. Okay? I can give you 2 weak acids. That doesn't mean they're equivalent. Okay? One weak acid might give off its hydrogen a little bit better than another one. Okay? There's a range. Then we talked about concentration versus strength. If I say strength, I'm solely talking about its ability to give off its hydrogens. If I'm talking about concentration, I'm talking about how many hydrogens then you have in solution. You could have a strong acid be very unconcentrated or dilute. Okay? Remember the example I gave you yesterday? Probably not.
I have an idea. Is boric acid an eye drop something? Would that be right or no?
Right about what?
That it's, maybe it's not a strong acid.
Boric acid isn't a strong acid because there's only 6 of them, but
I just never seen that in the book, but it's fine.
that it was a strong acid or what? Well, okay, yeah. So let's say I've got HCl. Is HCl classified as a strong acid, yes or no?
Yeah.
Okay. Now I know that however much I have of this will completely dissociate. Okay? So no matter what, it's always classified as a strong acid. Make sense? Okay? But could I have a small amount of this or a lot of this? Okay? That would be the difference between really concentrated or dilute. Does that make sense? Okay? So in both cases, whether I have a lot of this or a little bit of this, it all what?
Goes away.
It all dissociates. It all will go away to produce this. Okay? So the difference between strength And concentration is that strength is just defining its ability to completely give out hydrogens. Concentrated, or concentration is how much then do you have dissolved in solution. Okay? Continue on. Did we talk about this yesterday?
I don't.
Oh yeah, I began talking about how Ka times Kb equals Kw. And I made that little typo and then fixed it at the end.
And that's how it's done.
Okay, good. Alright. So, we've been doing equilibrium expressions for quite some time, so I'm not gonna, beat this any more than I already have. This is just the equilibrium expression for an acid, and Kv is just the equilibrium expression for a base. Okay, the cool thing about it is if you have an acid with its conjugate base, and you write those two equilibrium expressions, things cancel out, so you're just left with H3O plus and OH minus, which is what Kw is. I told myself when I was student teaching I would never let students just sit on.
Well, he's giving up his test.
I did it yesterday, that's it.
Because when I student taught with a really good teacher and a really bad teacher. The really good teacher was awesome, and then the really bad teacher, kids would lay on. They'd be laying up here, falling asleep during class.
Don't you do that though, as a teacher?
You mean when my back hurt really bad and I laid on the ground? That's different. Couldn't help it. I still did my job. I still did my job. Did I not? I taught from the floor.
You barely know.
What is that?
I didn't do that.
What is that shirt?
I forgot we had a camera.
You literally listen to Gage's Supreme rants every day on the
That's
camera.
All concentrated acids are strong.
False.
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 Right? Concentration just means how much ions do I have in solutions. Strong acids can either be really concentrated or really dilute, depending upon the situation. Okay? The name strong acid only defines complete dissociation.
So can you just simplify and say concentration is amount, and wow, strength is completion? It's not really.
Sure. All right. This shouldn't be overly difficult to explain, but this is talking about conjugates and their strength then. So you guys remember when we talked about an acid gives off a conjugate base, and a base gives off a conjugate acid, and they only differ by what?
One proton.
One proton, okay? So, quickly, I'm gonna write with water here, just
Oh, I was so confused.
What?
Right with
You
water.
said you were gonna write with water.
Oh, with water in it, okay? We said this is our acid, what is the conjugate base of that?
Cl minus.
CL minus.
Good job, Tanner.
Okay? Now, I said that this was a strong or weak acid.
You said it was weak.
You said
It was strong. Hey.
It's one of the 6 strong
I
acids.
was reading.
No excuses. You were wrong.
Okay. What they're saying is that if you have a strong acid, its conjugate will be weak. I'll explain. Well, what does a strong acid do?
Gives.
What does a strong acid do? How do you define
all of
it?
its
ions.
Releases, it will react completely and give off all of these ions.
Oh, so basically.
So the reverse reaction, do you think if this completely reacts this direction, do you think chlorine will react with this to produce something that always dissociates?
No.
No.
Yes.
How could you?
No.
Was it because I didn't react right away that you thought?
Wait, so is the reaction reversible then?
No.
This one definitely not.
Then why do you have one?
Because
God made it that way.
Why do you have one?
because most of the time they are reversible. Okay? In this situation, because this completely associates to form these ions, it would be completely contradictive for me to say that this is going to react with this to produce something that never will exist. It always completely breaks apart.
Wait, so they're only strong if the acid and the base. I mean, they're only reversible if both.
If you're dealing with weak acids or bases.
So it's weak because it takes it back.
Yep, because a base, right, we define a base as its ability to accept a proton.
The acid
And it isn't going to accept this proton because it would produce something that is strong. Now, if I had a weak acid, its conjugate base would be a stronger base, but I still wouldn't necessarily classify it as a strong base.
Oh, yeah.
Does that make sense? Be a little careful saying that. If I say that this is a weak acid, what we're saying is its conjugate base is stronger than this acid is. Okay? Which means, which direction does equilibrium lie? Far left or far right?
If the conjugate is
Yes.
to the left.
To the left. Which, what do we know about weak acids? They don't completely dissociate. So weak acids equilibrium always lies far left. That's because they give off a conjugate that's stronger. Right? So conjugate acid-base pairs are opposite. Strong acid will give you off a weak conjugate base. Weak acid will give you a stronger conjugate base. And you could say the same thing for a strong base would give you a what conjugate acid? Weak conjugate acid. Okay. Now, the real reason, I'm not going to talk a bunch about this, but the strength ultimately comes down to electrical charge. Okay? Things that have are not as attracted to each other are easily going to give off their hydrogen. Okay, and it's due to the idea that positives and negatives attract. Right? That should make sense. Okay, there's a lot of aspects of polarity that go into this, electronegativity values that go into this, and a lot of things to really understand why the 6 acids are really strong and the other ones are weaker. Okay. I'm not going to take a whole bunch of time going into the why behind it because I do a bunch of that in advance again. I don't think you're quite ready for that. Cool. But there's something to look forward to.
Wait.
Okay. Where those electrons are located will help determine whether or not the hydrogen is given off easily or a little bit harder. All right, I've been talking about this quite a bit, have I not? But I have not really defined it.
Oh, you said that once.
No,
Yes.
way more than once.
You've talked about how water can be either, but the first time I heard the word was yesterday. You said amphoteric once. And that was
No, okay. I maybe was talking about the, but without saying the vocabulary.
Yeah.
Okay, sure. What?
No, we did
No,
not.
I watched all the videos.
I thought I did too, but I might not.
Esoteric? You did?
100% positive.
Oh.
Okay.
Maddie's always right, she's a smart.
Can I take a picture of your shirt?
After Quinlan's the smartest.
Oh, you're right.
Why? You've been thinking about that for a long time. I heard you make some comment
Yeah.
about my shirt earlier. And you've been thinking about my shirt the whole time?
No, please.
That's a lie.
That's
Outside of the time you've been talking about Supreme?
What is your shirt anyways?
How you doing?
It's Kramer, smile, pose.
Is that Roman numerals for
Good.
7? I
Keep
don't
on going.
understand.
Yes, it's 7. It's an ultimate frisbee shirt. When
You
you
gave it
play
7
with only
players.
7 players, it's called you're playing savage.
You played Savage?
That's
I
what
thought it was
that's an
Savage.
ultimate frisbee term. When you have no subs, they say you're playing savage.
And you played like that?
This is just a company. There's
Oh,
you are
their
Savage.
frisbee
Did you
company's
play
called
in
Savage.
that
Have I played a frisbee game Savage? Yes.
Oh wow, Kramer's a
I
savage.
played Kingdom Tournament Savage.
Oh yeah? I bet they don't have a brand called Savage that's basketball.
It was me, Andrew, James Glenn, Bryce Crabb, and
Anyways, amphoteric substance. Okay? So like I began talking about the other day, a substance that can act as an acid or a base, depending upon the conditions, is called an amphoteric substance. And the number 1 amphoteric substance that we will ever talk about is water. I heard you say it, water.
Wait, so what else can be amphoteric?
I will give you some other examples here in a little bit. Okay? It acts the opposite of the substance from which it's exposed. If I put an acid in water, the water will act as a base. If I put a base in water, the water will act as an acid. Okay? Let's say I have something like this, HSO4 minus. Okay? If I put HSO4 minus in water, it will act as an acid. Okay? But if I put HSO4 with a strong base, nope, strong acid,
I thought HSO4 was an acid.
You thought wrong.
H2SO4 is a strong acid, HSO4 minus is an amphoteric substance. Okay? So here, I put this substance in water. This is going to act as a base. Now I'm putting this substance with a strong acid. Okay? This strong acid is going to dominate it and make this act as a base, actually. Use a different example.
Wait, how did water make it an acid?
Because water is weak either way. Like,
Oh.
water is a weak acid or a weak base, very weak.
Well, why couldn't water function as an acid when
In this situation,
Yeah.
because this is a stronger acid than this could ever be.
But why can't it just be a strong base?
How do you tell?
It's based on strength. Whenever one is the stronger version, is what's going to retain its natural or its desired tendency.
Like, how do you tell by looking at that that's a stronger acid? You just have to-
Practice.
Okay.
First off, you need to get familiar with the 6 strong acids.
So if it's
That's
not
important.
a strong acid, then it's amphoteric.
Not necessarily.
So,
Okay? So here's what I will
Yes.
say about amphoteric substance. Usually the things that are prime culprits of being an amphoteric substance are things that are weak acids, that are polyprotic, which I'll explain here in a sec, or diprotic, where they have multiple hydrogens. Okay? Let me give you an example. So let's say I have this guy, and I'll explain what polyprotic means here in a little bit. It just means multiple, more than 3 or more hydrogens that it has. Okay? This, when I put it in water, this acts as an acid. Okay? And this will act as a base. And the reason why this acts as an acid is because it's a stronger acid than this could be an acid. So it's going to act as then a base.
That makes
Okay? This would produce H2PO4 minus, because I lost the proton, right? Make sense? And that proton was given to water. Got it? Okay?
Yeah.
In certain situations, this could act as an acid. It could. Okay? Let me show you what I mean. Let me freeze this so I can have a little bit more room. Okay? This guy is an amphoteric substance. If I continue to put this in water, it will actually give off another hydrogen. However, it's much weaker. And the reason why it's much weaker, I'll just write this first. The reason why this is a much weaker acid than this is because of this. Why?
Already lost it.
Okay, it already has lost a hydrogen, yes.
Oh yeah, it's already given.
Okay. What are we giving off?
A proton.
A proton, which is positively charged, right? Do you think something that's negatively charged is going to easily give off something positive? No, because what do negatives and positive things do to each other? They attract. So it's more difficult to take another hydrogen away from this because you've got a negative charge and it's going to hold on to the hydrogen a little bit tighter. That's why this is going to be a stronger acid than this. Okay? So this is now significantly weaker. So if I take this weak acid and I plop it in a situation where it's with a strong acid, this can actually act then as a base. So let's say I take this and I put it in a strong acid. Which one's the stronger acid here? Okay, if this is the stronger acid, it's going to give off its hydrogen and this is going to have to take it. Making this a what? A base.
What if there is an acid
So,
base?
in this situation, it acts as a base, and in this situation, it acts as a what? Acid. So, the amphoteric substances are usually this. Water is the most common, okay? but usually the amphoteric substances are weak acids that have already lost a hydrogen and have a negative charge. Okay, that's the general culprit of an amphoteric substance. It is something that's already weak in nature. You take a hydrogen away from it, making it even weaker, and then you put it in a situation where you either force it to gain a proton or allow it to be in a situation where it still can give off a hydrogen.
What if you had an acid and a base and the amphoteric substance? What would happen to the amphoteric substance?
Like you had three things?
Yeah.
I don't really, I've never really dealt with that much, I don't know.
Okay.
You won't ever have to deal with that. You got three variables there, I don't know how that would depend. It would be, you'd have to know a lot about what the acid was, what the base was, and then what the amphoteric
If
substance.
things want to be stable, why would H2PO4 go off?
Why would it?
Yeah, because it's
That's a really loaded question.
Everything you've learned is wrong.
everything is wrong.
Well, remember, chemistry
Taught
is
you
the science of
lies.
exceptions.
I hate
It
that.
ultimately comes down to energy, but giving you the why behind that, let's wait till you take advanced
Answers
chemistry.
all my questions.
Okay.
I don't have the time to really kind of.
So it's okay if I don't understand.
Yeah,
Sometimes it's okay to not
I don't
know
know if
yet.
I'm smart enough to take advanced.
Oh, I think you are. Okay.
Wait, what did you say we're doing tomorrow in class?
Another lesson.
So I kind of already gave you this example when I said I was going to talk about polyprotic acids. Okay? We already know what mono means, right?
One.
Okay?
One.
Mono means one. This can only give off how many hydrogens? One. Okay? This is an amphoteric substance. It's weak in nature and has a charge. Okay? This is diprotic. It's the same, comes from the same structure,
But it has two.
but now it has two. Di meaning two. Okay? Same structure. Tri or a poly. Poly means three or more. Okay? If it has three hydrogen in it and they can give off all three of those hydrogens, we would call it triprotic. Now, question. Which one of these three, they're all weak acids, but which one of these three do you think is the strongest weak acid?
The one that's triprotic.
Yes. This one. Okay? Which one do you think is the weakest?
The monoprotic.
And why is this one the weakest?
It has least two atoms.
Thank you.
Okay.
Okay? Because what did we say strength is dependent upon? Its ability to
Yeah.
give its hydrogen. And if this has a really negative charge here, is it going to easily and readily give off a positive proton?
Why would it anyway at all?
It depends on the situation. If you put that guy in a really, really, really strong base, it's going to act as an acid. It depends upon what it's with.
So they're
Okay.
fighting over hydrogen, the base.
The way a reaction is going to work for acids and bases is primarily driven by what is the strong thing in the
Does
situation.
it have something to do with, like, as the contents of hydrogen goes up, the oxidation number, like 2 minus goes down? Like, yeah, with 1 it's 2 minus, with 2 it's 1 minus, and with 3.
Well, like when I lose a proton, that leaves this negatively charged. When I lose
Oh.
a second proton, then it
Sure.
leaves it as
Okay.
two minus. Yep. Okay. Now. Okay, let me see if I can get you to understand this conceptual question then. You just said this was the strongest version of the three, right? Even though they're all weak acids, which one would have the lowest Ka?
The one that gives most, right?
False.
Oh.
One that gives a
The
laser.
stronger the acid, the higher the.
I know that's on the next slide, but remember we said Ka would be your products, so your hydrogen that it gave off and your conjugate, okay? So it'd be your ions, right? And then your reactant would be your acid. I'm gonna write this all up, it'll help you. So let's say I have this. Hi. H3PO4 is going to give off its hydrogen because it's an acid. Please stay with me. That's the equation there. Okay? Acid base, conjugate base of the acid, okay? Conjugate acid of the base. Okay? Only different one proton, correct?
Yeah.
Okay? Can I write the Ka value of this? Okay, I'll say Ka1.
H2, 4, H3 over H3
Okay? And if this number is going to be high, which of these two needs to be the higher amount?
The top.
The top, right? Which means for a high Ka value, you want a lot of ions.
Yeah.
Right? And which one do we say gave off the most
The
ions?
triproduct.
This one gave off the most ions.
Why do you
So if
want
this gives off the most ions, it will give you a higher K value. What's your question?
Why do you want
Why do you want
ions?
ions? It's not whether you want it.
Why do you need more?
That just means it's right favorite.
I'm not sure what you're.
Why do you want more ions?
I don't want
He
more
wanted
ions.
he wanted the higher K.
I'm trying to show you the relationship between its ability to dissociate and its K value. There's a relationship. The more something dissociates and forms ions, the higher the K value. That's what I'm trying to make the connection for here. If this dissociates a lot, you have a lot of ions, right? So when you plug it into your equilibrium expression, you're going to get a high constant. If this doesn't break up very much, you're not going to have a lot of this. That means the concentration of this will go down, making the K value what? Go down. Okay? So if this dissociates the most, it will have the highest K value. And if this dissociates the least, it will have the lowest K value. So a way to determine the strength then of an acid is by looking at its K value. Okay? If a K value is high, it dissociated a lot, gave off a lot of ions. If a K value was low, it didn't dissociate as much, so therefore it didn't have as much ions. Okay? There's a relationship between conceptually understanding a vocab concept and mathematically understanding then your equilibrium expression. Okay, this just says diprotic and triprotic are usually classified as what? Polyprotic. I don't think I'm going to spend any more time talking about that kind of concept. All right, this is what I've kind of already talked about. Polyprotic acids, their K values get smaller as they lose protons. It's exactly what I was just talking about. Let me show you. Go back here. We said which one had the highest K value? This one. As it lost a proton, it was harder to get rid of its hydrogen, so the K value lowered. As it gave off another proton, it becomes even harder to give off hydrogen, therefore the K value plummets and drops even more. For polyprotic acids, the strongest acid is when it hasn't given off a hydrogen yet. And as it starts giving off hydrogens, it becomes weaker and weaker and weaker because of the negative charge. It's electrical in nature. Okay? And that's what this says. They become more negatively charged, thus it's harder to lose a proton. Hard question, guys.
No.
Does it have?
I can tell I have pumped you with a lot of information because you're starting to like.
No, because it doesn't have 3 hydrogens, so false.
I can tell. I can tell you really have had to think about. Had the thought. Sorry, had to think about this stuff, and that's good. You should have to. All right, last thing. What's the matter?
No.
I was forming them out and then.
Okay, and we're going to talk most of the next couple slides at a lower level.
Oh,
Good.
Yeah.
For us-
Good.
for us,
Change
Give us a
color with
break.
pH change.
Well,
Wow, pretty good.
unfortunately, guys, you guys do ask a lot of good questions. Like, no, let me explain why I say that's unfortunate. When you ask good questions, you're asking questions about the deeper stuff,
So you get more information.
but I need more time to be able to explain that deeper stuff. So a lot of times when you'll ask a question, I'm like, I know the answer to that, but I don't have
We don't
a
wanna
40-minute class period to go
I don't-
over that.
I don't wanna get
Not to
to
mention the other 40-minute class periods that I gotta set the foundation to then get to that point. Does that make sense?
Yeah.
So I like that you're asking those questions, but when sometimes I say I can't tell you the answer, it's not because I don't think you're capable, it's just I don't have the time to set the foundation for that yet. Okay, when you get into more complicated stuff, it starts to build. And that's why the other day I said a lot of times in chemistry I tell you stuff that's wrong.
Thanks for lying.
Kind of. Right? It's mostly right, but there are exceptions. But I'm going to give you the mostly right stuff so that when you have that good foundation, all I can say is, well, in this situation, it acts differently. Okay? So I know you guys, it drives you nuts. It drives me nuts as a teacher because I want to answer your questions. However, sometimes I theoretically, there's no way with the time that I'd be able to do that. So, the good thing about it is you can take another Mr. Kramer class.
Wait, do you really think
Oh, you touched it.
advanced chemistry is hard as college classes?
Yes.
Like, it's like harder. Same.
Depends on the college.
Is it worth wrecking my grade and?
Depends on what you value.
It's weighted though.
Depends on if you value GPA or education. Learning.
It's weighted, so.
I need money for college.
Unfortunately, our government has made a completely uneducational system in
What are
that.
your smart kids
Thanks,
really
Obama.
get in that class?
It is very hard. I think I have had 1 or 2 A pluses ever.
Okay, well I'm.
One D's not gonna ruin your
A
grade.
good student will get an A minus. A really good student usually will get an A
I
minus.
am not even getting any focus in here right now.
You've been taught a lot of numbers.
Oh,
That's not
it's-
fair. You're still smart.
So, can I finish here? Indicators. Okay? An example of an indicator was litmus
What I
paper.
need to do is just live here. How to live here?
Live under Kramer's desk.
I'd love to show you a text I got from a student saying that their college professor used a bunch of my material after a student showed them my stuff.
No way. That's so fun.
You showed us that freshman year.
I remember that. I wrote it,
Show
yeah.
us because we don't have
Guess what college that was?
So chemistry.
Are they like,
Yes.
go to Jordan? You went to Orange State.
I went to Northwestern.
So
It was really
like
kind of
revival.
close. Yeah, I was kind of a.
Living
Yeah.
so they might also.
I'm telling you, I know that some of you probably don't want to take advanced chemistry, but if you have any desire to go into anything medical, anything science, you are doing yourself a disservice by not taking advanced chemistry. Also, if you're a student that doesn't desire that, but you desire being challenged and growing as a critical thinker,
Dude, I love
it's another thing that you should probably take advanced chemistry. It will not be easy, it will be hard, however, there is a value to it.
Quinlan,
Hey.
is one of those cameras that will make
10 o'clock.
Okay, so, litmus paper is an example of an indicator.
Yeah.
Does change colors based upon whether it's acidic or basic?
Yeah.
Whether it has an acidic pH or a basic pH?
Yeah.
Okay, that is a very simple version of an indicator. Okay, there are lots of different indicators. Okay, they are nice in some sense because they can give you a rough estimate of a pH, but they're not going to be as exact if you took a pH meter that specifically measured exactly what the pH was. Okay, so there are some uses for it if you want to find a quick estimate. However, there are some very much there's some limitations to them as well. Okay, what an indicator is it will change colors based upon the pH. Okay, so this is actually how it works. What you have is its indicator in its acid form will be one color, but when you convert it to a base, it will act as a different color. Okay? So it might be red as an acid, but if you give it a base and change it into a base, it will act blue, or it will turn blue. Okay? And so what you can use is various different indicators. Some might change colors between 2 and 3. Some might change colors between a pH of 9 and 10. There's a variety of different indicators. Okay? If you put them all together, you get that universal indicator that you may have seen. I don't know if that's what you use, Gage, when you do your pool. Okay? Where you've got a big spectrum. When it's light yellow, it's between 1 and 2 pH. When it's a little bit darker, it starts to get orange, it's between 3 and 4 pH. Then don't use that. Use a pH meter.
Red and blue.
Once it starts to get a little bit redder, then maybe it's like 6 pH. Okay, stay with me. I'm not quite done. Okay. A transitional interval is the interval when you see a color change. And let me show you the next slide quickly, and it'll make a little bit more sense what a transitional interval is. This is a bunch of different indicators. Okay, these are the names of the indicators. Okay. What this says is, let's just say I'm using bromothionyl blue. Okay. The color change happens at what pH? Approximately 7 on the pH scale. If I'm anywhere below 7, what color is it?
Yellow.
So I could be at 1 and it will still be yellow. I could be at 14 and it would be blue. The transitional interval is the short window where you see your color change. The transitional interval for this would be like approximately 6 to 8 or 6 to 7.5.
Wait, so do they have ones that are like red, orange?
If you put them all together, you get that universal indicator that I was saying. Yep, that's where you have that slow color change over the course of the whole entire pH.
You know what you can do? Give us assumptions and give us all those, and then we gotta figure out what pH it is.
Yeah.